Hi everyone, welcome to the TBR Webinar series. Today, Senior Analyst Stephanie Long and Nicki Catchpole will be discussing the emerging and evolving landscape of enterprise edge computing. Before we get started, just a few housekeeping notes. At the bottom of your screens, there will be a series of buttons. From left to right, you can access the slides, audio controls, Q&A, speaker bios, and our survey. After the webinar, you will receive an email with a replay link as well as a link to view and register for other TBR webinars. If you have any questions for us, please submit them in the Q&A widget in On24. You may also reach out to us after the event at webinars@tbri.com. Thank you again for joining us, and here is Stephanie to begin the webinar.
Great, thanks Sarah, and welcome everyone to our webinar on the Enterprise Edge. So this actually marks the formal launch of our formal research within TBR around the full Enterprise Edge market. We've been formally tracking the edge from a telecom perspective for a few years now, and decided that 2020 is the year to start tracking the overall Enterprise Edge market as well. So I'm Stephanie Long. I'm one of the lead analysts here at TBR covering the data center market, and that includes the more traditional data center approach as well as some of the emerging topics in the industry like hyperconverged, hyperscale, HPC, security, cloud components, and quantum computing. And as Sarah mentioned, Nicki Catchpole and I have teamed up to bring our individual expertise together to track the enterprise edge market. She's a senior analyst on the cloud team here at TBR, and she tracks a variety of aspects of that cloud space. And as you're likely aware, the infrastructure as well as the cloud are both key pieces of the overall edge story. So many of the slides you're going to see today will be featured in TBR's inaugural publication of the Enterprise Edge Compute Market Landscape, and that report is coming out on Friday, February 28th. So if you have any questions during this webinar or would like to learn more about how to access either the enterprise or telecom edge research streams, you can use that Q&A function on On24, or you can email either of us directly, and we can follow up with you after to answer questions like that. We'll also follow up with you after to answer any questions that we don't get to live today via email. So you can look for those following the webinar if we don't answer them today on the webinar. And if you're a current TBR subscriber and you're curious if you already have access to this research, you can, again, drop either of us an email, or you can reach out to your account executive. Either of us will be able to answer those types of questions as well. And as you probably know, our portfolios are always evolving to meet the demand of these emerging markets. So it's never a bad thing to just check in and see if anything's come up new that could be added to your account. Check with your account executive. So anyway, on this webinar, we're going to cover how TBR defines the enterprise edge, our estimates on the forecast for the enterprise edge, some of the drivers and inhibitors to edge adoption, and then we have some vendor examples and use cases that we're seeing both established and emerging in the market. So with that, let me turn it over to Nicki to go over how TBR defines the enterprise edge. Nicki?
Hi, everyone. Before I dive into the taxonomy of the enterprise edge, and without dropping a series of terms as well as the taxonomy on your laps, we thought that it would make sense to at least pay respect to the evolution of where the edge actually came from. The journey to the edge, and this comes to no surprise to anyone listening, I'm sure, has not been linear. And rather, to steal a couple of the inputs we've had from some of our the vendors we're going to profile and that we've spoken to, it acts as more of a pendulum of sorts, swinging from the centralization of the mainframe world, dispersed to the distribution of servers, back again to the centralization of the cloud, and then here we are again with the edge, which everyone knows is centered on the proliferation of many devices, many sensors in many disparate locations, all then feeding back ultimately to the cloud. So while previous swings of the pendulum were thought to replace previous technology, what we wanted to emphasize here is that edge computing is not a replacement. of the cloud or of any of the previous technologies, but rather it's a build on the capabilities enabled by both the cloud, hybrid cloud, data centers, and everything that led up to it. Industry consensus is, and TBR tends to agree, that edge computing will unlock a new era of innovation, and in conjunction with the cloud, will define how applications are built out for the coming decade and beyond. So we keep this progress and uptick in implementation in mind when framing our thinking in general, with whether it's with regards to the market size, use cases, or how we talk about the edge in general. And that's a large part in why if you look to the far right of your screen, why there's a big question mark. We simply do not know in many cases where the edge is leading in terms of detail, but we do know that it's pretty much here to stay and that the evolution will continue. So to say that defining the enterprise edge computing market is not a straightforward exercise is definitely an understatement, to say the least. When researching the market landscape report that Stephanie referenced, a question we opened with when interviewing our profiled vendors was simply this: how do you, company XYZ, define the edge? The responses we received were wide-ranging, sometimes high-level, and at other times extremely specific. And some memorable descriptors include, and I did steal one earlier when I referenced the pendulum, was, it's a pendulum, or it's a cliff into the unknown, it's the future. And so that also harkens back to the image of the question mark, is that a lot of the edge is just simply that unknown. There are some things that can't be disputed, however, and first and foremost, the few are, there is never any issue or contention when it comes to agreeing upon the distributed nature of the edge versus the cloud. There's also the fact that I mentioned before that the edge isn't replacing the cloud. And as well that the edge is hard to define for reasons in that latency and analytics are both two critical elements impacting the value that it brings to the market, but just in and of themselves rely on different sides of the spectrum of those benefits, which we'll get into later, but one being more of a short-term benefit where latency comes into play, and the other with the longer-term benefits of analytics, where you get into the longer-term cloud, AI, machine learning, and all of the other adjacent technologies that the edge enables. The enterprise edge becomes nuanced and hard to nail down when factoring in the broad spectrum of industries encompassed by the term enterprise. Edge means different things to different industries, and the very factors of latency and analytics that end up defining the edge are also part of the reason why it's so difficult to nail down and define. At TBR, when focusing solely on edge in the telco vertical, we originally landed on a definition that is anchored in latency thresholds, contingent upon the speed of light. This is what we have decided still to apply to our overall edge taxonomy, with some variances that are made more clear by each vertical, which will become more apparent when we get to the use cases. So with that preamble addressed, the TBR addresses the edge compute market size aligning with the telco market definition. This includes the technology inputs to build an edge environment as being within 30 miles of the data generation sources or at a 10 millisecond degree of latency. And the reason why 10 milliseconds is the line in the sand is simply because this is the maximum threshold for low latency services and also contingent upon the speed of light. Items in the edge compute taxonomy include other areas such as data center equipment, servers, clusters, gateways, storage, networking, optical interconnect, just to name a few, in addition to services attached or related to this infrastructure. Close to the box software, such as data center infrastructure management software, which includes operating systems and virtual infrastructure management, as well as related platform and analytics applications are also included. Items included in the edge computing report are covered, but outside of the market size that Stephanie will touch upon are addressed. However, and these include the infrastructure utilized for metro, regional, and national network domains, and that's outside of that 30-mile threshold, as well as any on-point, also commonly referred to as IoT devices and sensors. So again, we recognize that these components are essential to the discussion of the edge. We just simply do not include them in our overall TBR market size of this technology. This next slide is really just a graphical representation of what I just went over, breaking down the far edge network with that latency and mileage threshold into its various components. As you move from right to left, we go from the two areas that are covered in our market size, again, at the highest level being the network edge and edge clusters and gateways, all the way to other areas that are, again, equally important, but that do not play into our market size, again, being devices and IoT sensors. So we just, again, wanted to call out visually that all of these are included in our discussions as well as use cases, and that as Stephanie presents on the market size, the two boxes to the farthest right, taking also into account those thresholds of the speed of light come into play.
Okay, so this chart here on this slide shows you TBR's estimated market forecast for the total enterprise edge market. The lighter green is the telecom subsegment, and then the darker green is all the other enterprise edge spend that we're forecasting here. So overall, we're predicting the market is going to grow pretty rapidly at about a little less than a 40-degree CAGR between now and 2024. But as you can see, we think a lot of that growth is going to come from the telco side of the market. And in particular, we think that this is going to come from that web scale subsegment of the telco market. And just to set the stage here, the TBR defines web scale as an internet-based digital platform company that operates ITC environments on a large scale. So when you hear that term, web scale, used throughout the presentation, that's what we're talking about. And we use that term a lot in the report as well. So anyway, web scales are poised to growth, and enterprises are increasingly looking to consume edge as a managed service. At least we're seeing that there are a lot more customers considering that as an option anyhow. So AWS is a nice example of where we see this trend shifting and how it could effectively consume hardware as a managed service and provide that to its customers. So AWS will buy, stand up, and manage the hardware, and the enterprises will pay a monthly fee for the service. So in terms of the enterprise edge revenue here, AWS, who is likely to be buying its hardware from ODMs, would be the one to realize that infrastructure revenue and effectively take that potential opportunity away from some OEMs in the market, because the customers that would have been an OEM customer consumed that as a managed service. So if enterprises buy their own hardware, that would go into the revenue here. And ODMs don't typically provide those close-to-the-box services and software offerings that OEMs do, so there is still plenty of opportunity for both in the market. We're just highlighting this example relative to web scale here. So that's where the web scales like AWS step in and fill in those gaps and provide that service. So, so now within the OEM landscape, we're seeing a large part of the edge revenue is coming through hyperconverged sales, actually. Hyperconverged infrastructure is sometimes referred to as a data center in a box. So customers can kind of take these and set them up at the edge, and it's sort of seamless because you already have the software bundled in with storage and such. But there are also ruggedized servers that are being created by vendors as well for the edge. Hyperconverged can't be placed in just any old environment. You know, it has to be temperature controlled for those HCI boxes to succeed. And so there's certainly demand from customers to put edge devices in a more temperature controlled environment, but also in a more rugged environment as well. So having both of those offerings is going to be valuable for OEMs. And I just want to reiterate here that our edge revenue figures do not include the devices and the sensors. So we're talking about the infrastructure that supports these, but not the devices and sensors themselves. However, having those edge devices and sensors as part of the larger portfolio, like Lenovo and Dell Technologies do, that seems to be an advantage because these vendors can sell across their portfolios, and as commoditization hinders some of their data center hardware sales, it also provides these vendors with a pull-through opportunity to sell the devices and the sensors on top of that hardware. So the overall deal can become more profitable as a result. But on the whole, we do see that the OEMs are likely going to be competing against each other. Market factors like commoditization and that increase in ODM revenue that's going to be realized because vendors like AWS start providing edge services as a managed service. Okay, so I talked a little bit about hyperconverged with relation to edge on the last slide. So here I wanted to show you some data that we have around edge in the hyperconverged market. So this data comes from our hyperconverged platforms customer research. And so just to give you a little background on the details of how we gather that data, so we survey 200 hyperconverged customers every 6 months. All of the customers that we survey are from North America, and they have already purchased hyperconverged. That's a requirement in order to qualify for the survey. So these results show what current hyperconverged customers are doing and what they are using their infrastructure for. So when you're looking at these graphs, we only surveyed the actual hyperconverged customers. We did survey 200, and if you look at the graph on the right, you can see that the end size is just 141. So that's because those are converged infrastructure customers. That's why those end sizes are different, because not all hyperconverged customers were also converged customers. So that's why there's a little dip there. So anyway, if you want to learn more about the report, shoot us an email and we can get you the details on that. But the point I'm trying to make here is that if you look at the bars for edge compute as a workload running on HCI, you can see this rapid increase between 1H19 and 2H19. It's highlighted this green box here on the chart on the left. So that is showing the rapid gains in a nascent market, which is a lot of opportunity, as you saw in the market share data, because the edge market itself has a lot of opportunity, as does the hyperconverged market. So you can also see that there are customers leveraging CI for the edge as well. And it can be a good choice, but hyperconverged tends to be the more preferred option because of its nimbleness and its sort of prepackaged nature. But that's like half of customers using hyperconverged that we surveyed are using it at the edge. So if you dig deeper into our research from this report, you'll see that incidence data suggests that only about 1/4 of the folks surveyed initially were even existing hyperconverged customers. So the other 3/4 get booted out of the survey because they don't qualify, but we still get to see the percentage of people that were and were not hyperconverged customers. So take that fact, it's about 1/4 of the people surveyed in general are hyperconverged customers, and then of them, 50% are leveraging hyperconverged for the edge. So that means that there is still a significant untapped market that needs to first consume hyperconverged, and then it would deploy it at the edge, or it could do both at once. So you can see that there is a big potential opportunity there. And it's an OEM opportunity because customers leveraging hyperconverged are doing so because of the support vendors can provide. And ODMs can't offer that. They just don't. It's not part of their portfolio. So customers can only get that from an OEM or a service provider offering managed services at the edge. And now, while these aren't ruggedized, so they can't be put in all environments, they are certainly useful in many edge environments that are temperature controlled, like retail, for example. You probably wouldn't stick an HCI box on an oil rig or something like that, but many of the vendors that offer these hyperconverged solutions also offer ruggedized servers as well. So these vendors can bundle different capabilities together to sell an edge portfolio, so to speak, that they could spin up at the edge for the variety of infrastructure needs those customers might have.
Mine's a question.
Okay, so the market is obviously not that cut and dry, as you know. Things like the managed service offering, which is enticing to some, is going to fall flat with others because some market adoption inhibitors like security concerns with skill shortages, things like that, those make some offerings enticing, and they make other offerings maybe less desirable to these vendors. So there is a need for these variety of offerings to be offered in the market to meet the demand of the variety of customers. So what we can say for certain is that these market drivers and inhibitors will dictate adoption to a degree as customers weigh the pros and cons of edge installments. Even something as simple as securing the supply chain to ensure sensors and edge devices were not tampered with in transport can have a profound impact on customers' adoption choices at the edge. But what we do know is that there are a lot of benefits to customers to adopt edge infrastructure. Some key ones are the fact that these customers are already paying for the buildings at the edge, so it sort of reduces the potential footprint of spinning up more data centers. You can put little mini edge data centers on location for things like retail and financial services and existing buildings. And the lower latency is also something that's going to increase opportunities and data value and make the edge's return on investment faster and more attainable. So because these are many of the drivers and inhibitors of edge adoption, vendors need to respond to these to encourage adoption for both their customers or prospective customers by alleviating these inhibitors with innovation or innovating to cater to the drivers. Okay, so as part of nearly every large digital transformation project, cloud has allowed customers to apply technology to their business challenges and improve agility, which in turn enables them to take advantage of emerging technologies. So edge computing enables customers to move onto this whole new set of use cases that extend beyond the centralized cloud model, but also raises questions around government cost and security, which creates opportunities for vendors to layer in services sales with edge infrastructure purchases or in partnership with this infrastructure vendor. So I want to emphasize, though, that the cloud and the edge do not compete, but rather work together to enhance each other's offerings to customers. Customers can extract more value from both the edge and the cloud when leveraged together than when leveraged separately. So consumerization of business applications, demand for data quality and governance, and the adoption of connected technologies have compelled vendors to explore opportunities around managing customer data and to invest in solutions that can help them protect their competitive edge. So targeted solutions, often targeted based by vertical, coupled with holistic portfolios, can determine the leaders in the edge. The majority of vendors in this space currently are hardware or cloud-centric, but as edge use cases increase and mature, the play for services vendors is going to increase. So I just wanted to highlight a few vendors in this space that we think have some unique offerings. So first I wanted to highlight Lenovo as one example. So Lenovo has minimal legacy hardware in its portfolio, which kind of gives it an advantage over some peers, but also enables them to focus more of their emerging tech and their budget to that for R&D and things like that, because it doesn't need to innovate to support that legacy side of the business because it doesn't have that. So if you add this on top of the fact that Lenovo also offers IoT and devices, it's able to address a large span of demands from customers, and that's reinforced by its hyperscale capabilities that Lenovo has with its ODM Plus business, which is also very unique for an OEM like Lenovo to have. So while Lenovo's individual solutions may not be the ideal fit, and the fact that it has limited services offerings could be a hindrance, when you combine its ability to play across the portfolio with ODM Plus, with its data center portfolio and with its devices and IoT capabilities, it makes it an attractive choice to the market, especially if you want to work with fewer vendors. So providing that span is helpful, and then Lenovo could either internally invest to bridge that gap with their services, or they could also pursue a partnership to sort of bridge that gap as well if that's what they chose to do. So an example of the value that Lenovo could bring is that it leverages AI, edge, and IoT capabilities together to implement a loss prevention solution for retailers. So there's this example that Lenovo has in its edge portfolio, and it involves security cameras, which act as sensors, and then the video streams can be encoded and sent to low latency, high speed, interconnect to an edge analytics server, which analyzes it in real time and then returns that to a store clerk who might be standing near the kiosk and can prevent the theft from happening because it's been notified, that person's been notified that something happened that shouldn't have. So they can intervene and prevent that loss. So this is an example of something that's horizontally scalable, because you can sell that same solution across a variety of stores. And it's also not very expensive to implement, but also has a pretty swift return on investment, especially if your retail facility is one that is plagued with a lot of theft. So there's an example of how Lenovo's sort of diverse edge-centric portfolio can help with a reasonable use case. So the other example I had here to share with you is AWS. And they already have solid market share in terms of their core central cloud, as we all know. And this is a key piece of the edge overall, as we said, because the data, once it's collected at the edge, to be analyzed has to go somewhere. So having that cloud play is really important with relation to Amazon. But here's an example for you about how AWS's solutions can play in. So if there are a lot of car accidents, for example, at a given intersection, sending that info to the core for processing and analytics, and then sending it back to the edge for implementation and large-scale change. So AWS also has those outposts. I'm not sure if you've heard about those in the market, but they are relatively nascent. And they're not designed specifically for the edge, but we think they are likely to be leveraged at the edge. It's basically hardware that you get to consume as a managed service from AWS. So like little private clouds that you can install where you need them, and then they can tie in nicely with AWS's public cloud. And this makes AWS sort of an emerging competitive threat to the OEM hardware players because AWS is going to leverage ODM hardware for their outposts and then sell that as a managed service. And that if a customer chose to consume that managed service, it would likely be in place of purchasing their own infrastructure. So if they were to have purchased their own infrastructure, that likely would have been an OEM play. So those are just a couple of the vendor examples we had for this one. And with that, I'm going to turn it back over to Nicki, who's going to expand a bit more on some of these use cases.
So this is Nicki again. Thank you, Stephanie, for that overview. To begin an entryway into some more of the concrete use cases that reference some of the ones Stephanie started to introduce, what we wanted to do is layer on a couple of the preliminary and more familiar ones. I was told by some people not to mention autonomous cars because you all are sick of hearing about the example, but it's familiar, so we're going to go with that for the sake of this example. What I was endeavoring to do here is just to put a visual behind just the fact that Edge, that the value proposition offered by Edge is multifaceted, again with both latency and analytics as the most powerful and influential factors. And what we're doing here is just applying those kind of high-level use cases to that spectrum of benefits afforded by the edge. So, looking at your screen on the far left of the arrow, what you see is the need for the immediacy of processing or latency, and the action which covers the short-term, which covers that short-term need. It's here where devices and sensors and just the inherent need for a reaction time come into play. The rationale behind such reactions, again, can come in the example of the self-driving car, so accident detection. And, another example that I think is pretty accessible and easy to explain is, in healthcare. So for the immediate reaction to something like a time-sensitive healthcare need, here I believe we referenced the need for a diabetic having an insulin spike or issue and needing an injection. Progressing from left to right, the degree of latency urgency is still important but not as high. And this is where a degree of analytics starts to come into play. On-sensor or device information is sent to a remote edge infrastructure site. And again, we see remote is kind of taken with, it could be, as TBR defines it, less than 30 miles, but it could also be less than 30 inches. It really just depends on the actual individual use case. And the reason why the information is sent to this remote, quote-unquote remote site, is to account for the lack of storage space on the said device or sensor, and also the ability to apply analytics directly on some sensors. Continuing from the middle of the graph to the right, this is where the need for the longer-term analysis is sent to the edge infrastructure site from the cloud. This is where data is collected from multiple edge devices and infrastructure sites. It's processed and long-term ongoing analytics are performed, and in time extended to longer-term machine learning AI, and any other adjacent technologies that tie in and help make the real-time insights and turn into action and longer-term benefits. These technologies are especially critical as the volume of data continues to rapidly increase and the inputs are more and more complex. Both the vehicle and the healthcare example apply here on a much broader basis, affecting populations over time versus individuals in an instance of time. And here, pattern analysis and feedback loops over time can autocorrect for certain potentially harmful situations and optimize certain industries, and in turn increase revenue as well as revolutionize some of the ways in which people go about analyzing data and, in essence, going into business. Now, in considering the variety and volume of edge use cases, it's clear that the demand for the technology drives a substantial amount of opportunities across industries, and that there's clearly no one-size-fits-all approach. The edge will soon be everywhere, performing distributed computing across a multitude of devices in homes and factories, on farms, on oil rigs, in mines, and embedded throughout the fabric of public infrastructure. In fact, TBR came across a research statistic from a well-known consulting firm who was able to map out well over 100 use cases across 11 sectors that were both viable and proven to be implemented in over 3,000 companies. So as I've mentioned before, each industry has its own unique perspective on why it would adopt Edge and the benefits that it brings to bear. And this is just really what you're seeing, a sampling of those 11 sectors, and certainly I wouldn't want to drag you all through the 107, I believe it actually was, use cases that we researched. But we wanted to call out some of them that, again, were the most kind of not easy to explain, but the most applicable across that spectrum, so that incorporated both the latency as well as the analytical angle. And there are, in fact, a couple of that we wanted to call out that were supplied by one of our vendors that we profile in the enterprise edge market landscape, Atos. One being the smart city example, where in general the number of sub-use cases can be overwhelming because it, of course, crosses traffic, security, public health, retail, and everything in between, and all to the degree that they also are all interconnected. Video surveillance is an integral part of establishing any smart city, and the examples that Atos was able to highlight for TBR is not just confined to the capturing of images. So I don't want to cheapen it by saying just video surveillance, but I honestly don't even know if there's a term to describe what these guys are doing right now. Maybe it's digital signature. So this is just one example of that I'll supply of smart video surveillance in cities that is implemented by a solution that Atos supports. The example that they were able to provide is that a woman, for instance, with blonde hair, a red shirt, a brown skirt, and red shoes could be captured by any given camera, and that her features, in addition to what she was wearing at a given period of time and in a given place, will be logged for recognition should the need to track here within the proximity arise. And as you can imagine, this sort of capturing could extend to any given number of use cases. The woman could have been shoplifting. The woman could have been faced with an attack. The woman could have been in a position where she was reporting something that she saw. And so all of these, and that's just scratching the surface. But the point here is that video surveillance isn't simply just surveillance. It's a matter of being able to recognize code, store, and then also parse out that information for both short-term benefit, so if it was actually in fact an emergency that she was maybe facing, as well as longer-term analytics if she was part of a said traffic pattern that was causing pedestrian congestion. The media and entertainment category is one that it also spans multiple different sub-areas and has a whole lot of different use cases, casinos, amusement parks, I mean, really, AR, VR, you name it. Mentioning amusement parks, that's another one that is a use case that Atos mentioned that I thought was kind of accessible and one a little bit out of the norm of what we typically hear. The use case here is that there is a ride, it's a roller coaster, in fact, at a well-known amusement park at any, I don't want to say at any given time, but there were issues where it would periodically shut down, and that would put it out of commission for, in some instances, up to 5 days. with the implementation of Atos' Susquehanna Edge server, which has been described to us as a server about the size of a suitcase, would be placed within close proximity to the sensors on the ride and would enable real-time analytics as well as predictive maintenance, in addition to ensuring if there was any kind of threat or danger in the very immediate short term for any of the riders. So the end result is that the sensors are able to detect when the motor weakens and react if the issue is mission critical, as well as gather enough data over time to identify the issue before the failure resulting in little, if any, downtime for the riders. And ultimately, well, we don't have exact metrics. What we were told, the company saved a massive amount of revenue that came from having one of their main attractions running, and of course, also most importantly, enhances the safety of the riders. One of the use cases that I wanted to drill down a bit more deeply into is agriculture. The reason being is that, again, the field of agriculture it enabled me to apply this example across that spectrum of latency all the way to analytics. And the examples here provided are rooted in the autonomy of sensors and robots who can collect and analyze data and all underpin the technology of precision farming with the goal of ultimately improving yield, but there are also many other ancillary benefits. The examples highlighted here include agrobots. That's the first time I'd heard of this in the last couple of weeks. So these are agricultural robots who receive information from sensors and perform tasks such as crop harvesting and irrigation. They collect information that they're seeing literally in the field, react as needed, and then also in keeping with the general theme, parse and send it back to the cloud for longer-term analytics and data aggregation and storage. A second example is climate monitoring. So this is taking outside of just the immediacy of a given farm itself, whereby sensors on that farm, however, would collect and send data to the cloud in the climate that is directly attributed to the farm, as well as climates that are surrounding the farm, as well as any other climates that might mimic what that particular farm may experience. So this is more of a longer-term play. Like climate monitoring was another one that we thought was important to call out here. And the third being crop management. We'll also kind of include livestock management as well. So just essentially managing the health of your lifeblood of the farm, whereby sensors can not only detect in a field a need for immediate attention. So let's say harmful parasites are unknowingly starting to attack your crop and you just haven't seen that this is happening yet. Or there are a couple of your cattle that just have suddenly stopped eating. So you can also see here how this example could extend to near-term latency potential, as well as over time provide the ability to predict when any of those flags happen to come into play. The next use case that I wanted to touch upon is retail, and this is probably personally my most favorite one, but I'll leave you all to have your own opinions. The advent of online retail has, of course, been a blessing for many shoppers like myself, who enjoy the 24-hour ease and convenience of buying literally anything that our hearts desire from anywhere that really has a phone signal. So it's no surprise to hear that brick and mortar retailers, and these can range from mom and pop shops, but really we're focusing more on the full-scale department stores, have started to feel the effects of living in quote-unquote Amazon Prime world. And in response have started, so that they don't become obsolete, have started to implement some really interesting tactics to improve employee productivity, and for all of us consumers who choose to leave the house out of our pajamas, the overall shopping experience. In-store robots is the first example I'd like to highlight, and they have functionality that's twofold. From a productivity and labor optimization standpoint, robots can simply replace some human functions such as shelf stocking, inventory counts, just more efficiently and accurately than humans, and in conjunction also free up people to do more of the face-to-face interaction with customers themselves. That being said, on the actual floor and interacting with customers, robots may also act as assistants or even personal shoppers. And the use cases here range from a simple Q&A regarding preferences to some personal, what have been called shop bots, who can analyze individual features and even clothing style to suggest things like potential outfits. I was going to add, I'm not sure how this works if you're prone to shop in sweatpants and are looking for an evening dress, and if the technology has it extended to include aspects like this, but I still think it's a pretty interesting case that kind of harkens back to the analytical ability as well as the sensor's ability to see something in front of them and actually create a smart suggestion that resonates with a consumer. In addition, another solution in the retail realm is video monitoring. So outside of robots, video monitoring can help retailers in a variety of ways, such as facial recognition to detect customer satisfaction, as well as on the operational side. Monitoring things like foot traffic flow to help managers make decisions with regards to staffing and closing hours. And finally, to round this out, another personal favorite example of mine is the extension of personalization, the main benefit of which is improved customer experiences. AR mirrors have been shown to be implemented to allow someone to try on clothes, for instance, to account for an item that A, may either be out of stock, or B, assist in showing someone what a different size would look like without them actually having to try it on. Another example is AR/VR to simulate a destination so that, for instance, someone trying on a bathing suit for an upcoming trip could have the experience of doing so on a tropical beach versus a harshly lit changing room. It's never a pleasant experience for any of us who have had to go through that. So that's another just real-life, really accessible consumer example that we wanted to work in here outside of just speaking solely about factory floors and more of the mechanical operational aspects of things. This in conjunction with the farming example, or more precisely the precision farming example, are examples among many others of how the implementation of edge technology and incorporated analytics can optimize staffing, predict buying behavior, control inventory, and create an overall more satisfying experience for the shopper, and in the case of the farming example, help with safety, crop yield, and predictive analytics to make sure that the farmers are getting the most out of their land. Of course, all the use cases that I've highlighted here so far, plus the multitude of others that are out there, are all varied and with their own nuances. But however, despite the industry, the locations, and even the complexity of what we're dealing with, there seems to be a common thread that underlies all of the components that are brought in to activate the deployment of the edge, and that's the management component. Who is actually taking care of all of this stuff? It's an understatement to say that the number of devices and servers has increased dramatically, and when clients adopt edge topologies, in many cases, they'll have to manage thousands of servers or hundreds of thousands of devices, and this list just is constantly added to. On top of that, in most cases, these devices are not standardized, and that means there's a lot of variability at scale to deal with when deploying workloads at the edge. Existing management approaches were not built traditionally for this type of environment, and as a result, there's a need to standardize and normalize the technique for creating applications and management styles to get the right workloads to the right clients and at the right time, while still controlling the build-out of scale. With a solution that offers automatic capabilities, one admin can in fact manage tens of thousands of edge endpoints by offering autonomous identification, agreement, verification, and execution of management actions. So that being said, we have not seen a lot of examples of this kind of autonomous management out there in the marketplace. And when one came to our attention recently when speaking with one of our vendors, in this case IBM, we felt like it was one worth highlighting in conjunction with this report, as it really does address some of the main struggles and challenges faced any organization, no matter where they are on their journey to the edge. This next slide serves to just represent the scale of the multitude of servers and devices that I already referenced that have to be managed at scale and in many different dynamic environments. What IBM has created in response is an autonomous offering to create, deploy, secure, and scale business applications and AI analytics across a full spectrum of edge deployments. Called IBM Edge Application Manager, This solution eliminates the manual and repeated tasks of deploying the thousands of edge endpoint locations across the edge devices, servers, and gateways. There are three primary pillars that this offering relies upon, which are, first, that it's intelligent. It's the industry's only autonomous policy-based lifecycle management platform, factoring in an administrator's intent versus requiring an administrator themselves to identify, initiate, and verify which management action should be taken and when. Second, security. There's not a whole lot of need to dig more deeply into the inherent importance of security, other than the fact that with the solution, IBM has certainly addressed it with an encrypted and secured solution that's also firewall ready. And thirdly, flexibility. IBM's solution enables the edge platform to run on anyone's public or private cloud with open standards based on OpenShift. The extent to which we wanted to highlight IBM here is twofold. One is to recognize that this company is running ahead of the curve to curtail the inherent challenges that come with the degree of dispersion, disruption, and all of the devices that come with the advent of any new technology. And edge computing is kind of the poster child of disruption in many different ways. The second is because this newly released technology is an example of how leading vendors are not just responding to the challenges and opportunities presented by the edge, and Stephanie went over a couple of these examples when she highlighted AWS and Lenovo as well, but that these vendors are preemptively considering what needs to be in place to facilitate their own growth as well as help the growth of the overall market. Now, hearkening back to the slide at the very beginning where I showed the evolution to the current state of the edge, again, the final image on the right-hand side of that screen was one of the question mark. The definition of what the edge is overall for enterprises, as well in a more isolated fashion for telcos, will continue to evolve as the concept of dispersed computing and the maturity of supporting technologies, devices, and connectivity mechanisms becomes more mature. In the midst of the unknown and uncertainty is that the edge isn't a trend or a phase. For now, we'll keep striving towards that proverbial question mark and look for examples of market insights and technological developments that are advancing the way that institutions, consumers, and industries function at large. Overall, we found that use cases, and that's why we feature them so extensively here, as well as technology updates, are the best way for firms like TBR to keep on top of such trends. And this is why we welcome feedback from the marketplace and everyone attending in general. So please don't be shy in reaching out to Stephanie and myself and sharing your thoughts, your feedback, and asking us questions. So with that, we do have a few minutes left to field a few questions, and for any that we can't get to during the session, Stephanie and myself will be in touch to respond and answer any of their follow-ups. So with that, thank you for joining TBR's first webinar on the Enterprise Edge. And with that, we will take the first question.
Okay, so we have a question here. It's about how we foresee pricing models going in the edge space. Will there be new pricing trends emerging? So that's actually a good question. So I kind of alluded to this in the beginning, but so we're seeing consumption-based pricing really resonating at the edge. Customers, in some cases, can't support the sprawl of the data center that edge is causing, largely due to the skill shortages that we know are prevalent in the IT space. So we're seeing the concept beginning to resonate with hyperconverged customers right now, actually, but there's a problem here with this pricing model at the moment, and that's that customers like how it sounds, and vendors have the capabilities to offer it, but the customers don't have the understanding necessary to translate the business value to the ones that have to sign on the line at the end of the day within their organizations. Because if you just do the math, these consumption-based pricing deals are more expensive than a hardware sale. But that's because it includes hardware, software, and services. And customers, they have to translate that value to the people who are signing the check at the end of the day at their companies, and that's proving to be a challenge. So we're seeing this at least occurring in the hyperconverged space, and are expecting that same challenge is likely to present itself in the edge market if the customers and the vendors don't find ways to work around it. So this next question says, you didn't really talk a lot about services. Could you elaborate a bit on your thoughts about that? So, yeah, so this one sort of ties in to the last one a little bit. So there's this significant opportunity for services at the edge because of those skill shortages, because of the impracticality of managing and maintaining all this edge hardware by themselves in-house. So, so there certainly is an opportunity for services in the edge market, and once edge adoption goes on that uptick, the need for service is going to increase as well because the edge is going to be spreading wider and wider, and having those services to support that are going to be very valuable. Okay, this next question says, what about adjacent technologies like IoT? So how's that going to impact the landscape? Okay, so just to emphasize here, like we said earlier, we don't include that like edge device revenue in our market forecast, but we do highlight it in the content of the report. So, so what we're seeing now is we're seeing some of these advantages for OEMs that also provide IoT solutions, like we talked about earlier, because they can sort of sell like an all-in option for the edge. You know, you can get the fundamental infrastructure, you can get the sensors and the devices, and in some cases you can get the services you need. In some cases you may have to partner for that. ODMs don't really have that as an option, so OEMs can leverage these adjacent technologies to help differentiate and combat some of these market trends like commoditization that are hindering them. So, so it's definitely a very important piece of the conversation here in the space. So yeah, adjacent technologies like IoT are super important to this overall enterprise edge landscape. Okay, and this next question says, we mentioned new research streams from TBR. What can you guys expect in 2020? Yeah, so we've been tracking edge for a while, like we said, and what we at TBR here, we do is we'll track a market for a couple of years until we feel that that technology area has reached an inflection point, and then we can launch new formal research around it. So recently, you can see that we've done this with topics like web scale and quantum computing. And so we certainly are keeping a pulse on some technologies that are emerging right now to see at what point in 2020 it might be the right time to launch some additional research. So if there are burning questions and topics that you are finding you just have to have research on, feel free to reach out. We can pass that feedback along to the appropriate people and see what we can do in that sense. So yeah, that's that. Okay, this next question has to do with use cases, so I'm going to turn it over to Nicki to answer that one.
Thank you, Stephanie. I guess I'm the use case queen today. So this question is, one second. Okay, you had mentioned that there are a multitude, upward of 100 or more use cases that have been categorized by a certain advisory firm in the industries, in enterprise industries at large. Can you please elaborate on one or two of the ones that stuck out in your mind that may be more out of the box and incorporate adjacent technologies such as AI? So I'm not going to be industry specific in my answering of this one, and this might very adjacently incorporate AI, but it is a technology that was not addressed when speaking through any of the use cases or edge in general. So I think I'll end out the session. I probably have just enough time to finish answering this one. So one, like I said, this one is not industry specific. I'm just trying to think of how to frame it. This comes in the type of sensing and deployment. So I'm not speaking about on-device sensors or IoT here, as we've traditionally been speaking about them, but I'm referring to how drone technology fits into the whole scheme. And the way the couple of examples that I've encountered are essentially that drones have started to function as like their own flying on their own like mobile on sensor devices in and of themselves. So so for so rather than being stuck on a certain input mechanism, a vehicle or a car, or sorry, a vehicle or an airplane or in a factory, a drone can obviously travel over air or land, and that it enables the amalgamation and the sensing of a bunch of different input factors to really be much more dispersed than on a particular point of place. So my impression is that drones are in the process of being tested at the moment, that they're still not widely deployed when we're talking about the edge. But we do think of them when it comes to things like smart cities, especially, or when doing city planning, how these could potentially apply, as well as there have been some thoughts around a lot of potential military applications that extend beyond what people are using them for even today. So that was just an example, especially because we always keep talking about IoT and sensors. So the dispersion, and keeping in the kind of the theme of edge being dispersed, sensors being dispersed with drones are potential use cases that we're hoping to get a better handle on and speak more to maybe in our next webinar. So with that, I think we've probably run through our time and our questions.
Yeah, all right, everyone. Please feel free to reach out to Nicki or Stephanie with any more follow-up questions that you may have. If you have a few moments, it would be greatly appreciated if you could fill out the survey on your screen. A replay version of the webcast will be available after the event and will be sent out to you via email. To view a list of our upcoming and past webinars, please visit tbri.com. Be sure to join us on Wednesday, March 11th for our Digital Transformation Buyers Ready for AI. Thank you and have a great day.